Well, good morning or good afternoon to everybody that's joining us, depending on where you are in the world. Um, we're going to give everybody about 2 minutes to continue to join, and we'll start at 2 after the top of the hour. Well, hello and good morning or good afternoon to everybody that's joining us. It's 2 minutes after the top of the hour, so we're going to go ahead and get started. I'd like to thank everybody for joining us today. My name is Brian Selvey, and I'm the Chief Innovation Officer at Zuken Vitech. And my role for today is to be your host. Today's topic is from operational context to system definition, mission engineering basics for system designers. We've got a number of participants rolling in, so I can see that this is a topic of great interest. And with us today, we have an exceptional subject matter expert whom many of you recognize. Before we meet our presenter, there's a couple housekeeping items that I need to cover. First, we are recording this webinar for your reference later, and it will be made available online. Second, you will see the control panel typically on the right side of your screen. You are muted by default, but we encourage you to ask questions. Please submit your questions in the question window, and we will answer them during the presentation or during the Q&A session at the end. Given the number of attendees we have, it's very likely we won't be able to answer all the questions submitted, but we will try to follow up with individuals afterwards and provide answers if need be. Lastly, we're going to ask 2 poll questions during the webinar, and we will share the results so you can see how others respond. Watch for pop-up windows when it's time for the polls. And with that, today I'd like to introduce our speaker, who is Daniel Nguyen. Daniel is a product manager at Zuken Vitech. He leads the specification, definition, and management of several Vitech model-based systems engineering software products. He has also participated in pre-sales technical support, business development, technology research, consulting for industry, and MBSE training in his previous roles at Vitech. Prior to joining Zuken Vitech, Nguyen was a systems engineer at Northrop Grumman Corporation, working on aerospace platforms for the U.S. Navy and U.S. Air Force. Daniel holds a bachelor's degree in aerospace engineering from UCLA and a master's degree in systems engineering from the Stevens Institute of Technology. Welcome, Daniel. Thanks for being here today, and let's go ahead and get started.
All right, thank you, Brian, for the introduction. Hello, everybody. I'm glad to be here with with everybody, and for today webinar, the focus is that I would like to introduce some of the very basic concepts of mission engineering, sharing with you my take on the value and the purpose of mission engineering, and also the enthusiasm, right? And so by the end of the webinars, I hope that everybody will leave with some encouragement to look into the applications of mission engineering and what it can do for the success of your organizations. All right, so with that, let's look at the agenda. So I will start with the purpose of mission engineering from the perspective of the systems designers. Then I'll go into an example scenario for the application of mission engineering, and then some of the uh, more specific examples of what you can do uh, in applying mission engineering to your product design, and then a recommended process if you choose to go that route, and then share with you a simple recipe for success if you choose to go the route of mission engineering, and then we'll have some time for Q&A. All right, so why mission engineering, right? Before we start in with adopting anything in our engineering process, we have to ask why we care, right? So let's start with this. So if you ask a pilot, more specifically a fighter pilot or strike pilot, what comes to your mind when we talk about working with airplanes, right? Or working with fighter airplane, right? So you might get this kind of response, right? So I'm not going to read the whole thing, but basically, I was cleared to Angels 350, so I did a Mark Hall climb up to 35,000. I fenced in and armed my weapons for engagement. I also pantsed up. So we were essentially NODO. Once I was feet dry, the picture was clear. I heard of vibrant eagles getting a duty, but it was in near opposition, etc., etc., etc. Right. So this is actually an example of an after action report, a U.S. Air Force after action report. And to a fighter pilot, for example, this would make sense, right? But to an engineer, it may not. It's very complex. It's really confusing, and it may not mean anything to an engineer or to a designer who also works with an aircraft. Now, so if you ask an engineer or a designer what it means by working with an airplane, you might get this answer instead, right? It's all about the architecture, the requirements, CAD models, control models, and so on and so forth, right? So I call this engineering stuff, right? And it makes a lot of sense to engineers, to designers, but it may not make any sense to a pilot, for example, to the user of an airplane. So what we have here is that even though the pilot or the end user, the customer, and the designer, the system builder are supposed to work together as stakeholders to design a system, these stakeholders might come to the conversation with very different approaches and very different priorities, right? For an end customer, right, they will want the most capable system, the least amount of time to deploy, the lowest cost to deploy, lowest cost to procure, also easy to use, easy to maintain system, right? They have their own ways of using a system, so they don't want to be made to relearn how to use a system, right? And maybe they have a very favorite components in the system that they want to use. That's what I mean by must include this lever, right? So if the parking brake on an airplane is usually controlled with a lever, they might not want to control that same braking system with a push button, for example, right? Now, from the perspective of a system builder, right, it's very different. The approach is very different, right? So they want to deliver a technically acceptable solution, right? They might need more time to do it right, right, to come into a bid with a reasonably competitive number, right? But at the same time, they might have some sort of gold-plated technology, overbuilding a system, for example, and then that will lead to a very complex system to use, right? Um, the supportability design might be second thought. This is where you have to deal with maintainability, accessibility, for example. If a component needs to be replaced more often, it should not be placed behind a component that does not need to be replaced as often, right? So things like that um, may not be the priority in the thinking of a system builder or system designer, right? And they might have new ways to design and also use the system, right? And that might not be what the end customer prefer, right? And then must include this box. So if you're an engineer, right, you probably have a preferred implementation, right? A commercial off-the-shelf box that your program or your company would like to use, right? So you will want to include that particular part into the design without knowing if it will um, uh, be useful to the operation of the overall system. So it boils down to a problem between the approach from the end customer's perspective and the approach from the designer's perspective, right? The end customer often finds it difficult to express their needs accurately and realistically through requirements, for example. And then the designer uh, is often lack a contextual understanding of the operational requirements. I know what I build, I know how to build it, but I have no clue um, what the purpose or how my system is being used by the operator or by the end customer. And with that, that will create, instead of working together to build a system, uh, the differences in approaches and priorities will create a barrier between the end customer and the system designer. And with that, I believe we have the first poll question.
All right, thank you, Daniel. I did want to just address that it looks like a number of people are noting in the chat that they can not see any slides. Um, Amy Clements says, if you're experiencing that issue, try to log out and log back in to see if that fixes the issue. But if that still becomes a problem, please, if you've tried that and it still is a problem, please let us know again in the chat. With that, though, we'll continue on in the interest of time. So I'm going to launch the first poll question, which is about for the designers and engineers out there, do you consider yourself an expert user of your own product? This is sort of to get a sense of sort of the variation in people that we have attending today's webinar. So as good at using it as designing it on one end to just being a user at the other. And we'll leave this poll open for about 1 minute. All right, we'll go ahead and close the poll and I'll share the results. And the results are in with 22% saying that they're as good at using the product as designing it. 53% are saying they have some understanding of its usage. 19% say they rely on customer requirements to understand its usage. and 7% say that they are users only. Any observations or thoughts or comments on the results, Daniel?
So actually, this is a very good mix of results, and but this is a really good result actually because uh, first of all, the it is good to see that a lot of designers out there also have some understanding of how the system is used, and therefore, they understand why they build a system. So that's perfect, right? There are still some designers out there relying on solely relying on the customer requirements to understand the usage. So at mission engineering will hopefully bring those designers into maybe the second or even the first categories in the poll questions. So with that, let's move on to why mission engineering, right? When done from the perspective of the designer, right? Mission engineering will help seek the enterprise perspective, right? Define the purpose, the context, the effectiveness of the design, right? So it will help you answer what the system is trying to do, why, and how well it will perform, right? It will identify the users, both external and internal, right? Identify the stakeholders of the ConOps of your enterprise, right? It will help you eliminate costly, complex, unnecessary features, right? The gold-plated technologies that system designers tend to build into their solution, right? And add simple features that will bring great value to the end customer, right? And also identify and address social and as well as technical issues. Not just as system engineering issues, but also social issues as well. So later on, we'll see a concept of air interdiction, right? So meaning that you will try to go into your enemy's territory proactively to defend your territory. So from a social issues, right? Is that a good thing or a bad thing to the image of a nation, for example, to the image of self-defense in the military doctrine? So mission engineering can help you answer those questions. So you see a lot of repeating theme, like why. You ask a lot of why questions when you do mission engineering. All right, so with that, let's look at a scenario, right? Look at the problem that we are trying to solve here. So the Air Force has a need to replace an aging multi-role fighter, and they have the short-term needs and the long-term needs for the system, right? In the short term, it needs to be able to perform counter-air operations to defend coastal regions and other critical land assets. So uh, try to remember this detail because we'll come back in our example. And then later on, for the long-term needs, it will need to be able to perform air interdiction, right, to strengthen the overall integrated air and missile defense system. All right, so the possible solution here is that there might be some existing fifth gen fighter options that are available for import, right? Maybe from direct procurement or for joint development and production. But also, there are strong options to design and build this new system from the ground up, right? And then you have, this is very critical here, you have the military and industrial complex support, right? They are open to maybe changes at the doctrine level or strategic and tactical level. So everything is a fair game here. All right, just a little bit of a disclosure, a note on information sensitivity. So everything that I will about to share with you is public knowledge, right? So no classified or proprietary or export control data in this presentation. Right. So one thing that we can do first in mission engineering from the designer's perspective is that we can look at the top-down missions, right? So in this example, we will look at the counter-air missions based on the U.S. Air Force doctrine. So with the counter-air missions, you can start to decompose counter-air missions to other types of missions, such as offensive counter-air, defensive counter-air, and so on and so forth. Um, and then when you get to the level of granularity, when you see area defense and point defense, then you can look at what the problem statements ask us to do, right? To defend coastal regions and critical land assets. So we know that our new aircraft here, the new system has to be able to perform or execute area defense and point defense, right? So this is the system solution that we are going after. But at the same time, if you look across the existing missions, you would see that for fighter sweep, for example, there might also be a existing solution already, a different type of aircraft that would perform fighter sweep, right? A different type of aircraft that would perform fighter escort or protection of high value assets, right? So then you don't because that you have already done a decomposition of missions, right? You may look across the doctrine to look at other operational solution that may satisfy the requirements for area defense or point defense as well, right? So maybe your answer to the problem is a reuse of existing systems to satisfy your new requirements rather than investing on in new systems, new solutions for the new missions. So after that, so that was from the missions perspective. So now what about the capabilities perspective, right? So now we know the missions, but then now we can trace the missions to capabilities. Now we can start with point and area defense. Again, do a decomposition, get to this level, and then we know that our systems will have to satisfy the capability to perform combat air patrol and ground alert intercept, for example, right? But now, again, we can look across the overall industry defense and industry complex to look at other existing capabilities as well. For example, ballistic missile defense or surface to air defense components, right? And then ask the question if the operational solution is what we are after, or there are other existing capabilities already available to be able to satisfy the new mission requirements as well. So look across your military and industrial complex. And then the next thing that you can do is that you can use mission threads, right? So what is a mission thread, right? It is a sub-element of the overall mission architecture, right? You can see it as end-to-end tasks or activities to accomplish a mission, right? They are very scenario or vignette specific. So in this example, we'll look at this conduct combat air patrol to achieve air superiority, right? So this is very specific to the example that we are about to see. So here it is, fly combat air patrol sortie with AWACS in the overall mission architecture. So what it is that, imagine that this is your point, the point defense you want to run the mission upon, right? You need to protect this point. So what you're gonna do is that you're gonna run a racetrack pattern with two aircrafts, two fighters on a cap, what we call a cap station, combat air patrol station, and then this is your threat axis. So this is where your the area where your enemy aircrafts will ingress and try to attack this point right here. So that's the scenario. So what you can do with the mission threat is that you introduce specific systems, technologies, and personnel to add to the mission threat to then develop a mission engineering threat. Right. In this example, we will look at a typical F2T2EA queue chain. What it is, it's a series of tasks or activities to find, fix, track, target, and engage the enemy, and then assess the battle afterward. So within this, the model, this is enhanced functional flow block diagram in Genesis. This will enable you to model the operational activities performed by different constituent systems. In this scenario, how they interact, the input, output, triggers, the structure of the behavior within this scenario. So for fighting, and I do apologize that the PowerPoint does not come across very well with the graphics here. But anyway, so basically fighting. So if you remember the scenario, this is where you have a two ship cap pattern with the support of early warning aircrafts, AWACS. So fighting will be performed by the AWACS. The enemy will approach the area where the AWACS will detect the enemy ingress, right? And then fix. AWACS will identify that threat, classify that threat. Then tracking. Now AWACS will track to make sure that the rules of engagement is satisfying, right? And then alert the combat air patrol aircraft to then conduct a checklist, targeting. So now the AWACS has assigned a target to the CAP fighter, right? And the CAP fighter can go ahead and jettison the fuel tank, start the intercept route, and so on and so forth. And at the same time, AWACS still monitoring the ingress of the Red Force. And then engage. So this is where you can model how your CAP fighter engages the enemy, right? Flying, maneuvering, and engaging with a weapon, in this case, an AMRAAM. And then finally assess, right? So both the CAP fighter and the AWACS will assess the effectiveness of the engagement, and then you can show that there are three scenarios: high threats, medium threats, low threats, and then depending on the condition, the AWACS will order the CAP to either establish new station, reroute to tanker for additional fuel, or return to base. So things that you can model with a typical CAP sortie. All right. So after that, what can we do with a mission engineering threat? Right. You can identify key operational activities, right, such as the queue chain activities, because as you can see in the example, there are other activities that are not specific to F2T2. You still want to show them for context, but F2T2EA queue chain activities will drive the requirements for your system design. Right? Identify key constituent system and resources such as the actual combat air patrol fighters, AWACS, command and control, and so on. All of the physical systems required to perform the mission. And then derive associated capabilities such as measures of effectiveness, measure of success, measure of performance, and so on and so forth. Right? And very important, identify system level implementing functions. So this is where you will eventually bridge the operational domain to your system domain, right? So in this example, looking at the identify threat activity, to be able to perform this activity, for AWACS to perform this activity, there are capabilities that have to be available, have to satisfy, and also there are implementing functions for the AWACS airplane to be able to perform this activity. So you are bridging from operational context here with an activity to actual functions that you can design into the AWACS aircraft. Right, so this is very quickly an example of uh, different measures of performance that you can write for your activity. This is a very quick example. I'm not going into the details here. And then, very importantly, so now that you have a mission engineering threat or threats, what can you do with them, right? You want to perform trade studies, for example. You will have the baseline mission engineering threats with different scenarios, activities, constituent systems, all of the key performance parameters and implementing functions. But then you would also want to develop other mission threats and mission engineering threats to then compare them, do a trait study to the baseline mission engineering threats, right? And from there, you can identify gaps in your doctrine, for example, at different levels, strategic, tactical, or technological level, and then find the best, the available, the balanced solutions to your problem, right? So some examples here, maybe you would want to baseline this air superiority with AWACS threats, but then develop another threat without AWACS, for example, air superiority, but at the same time defending AWACS, the combat air patrols having to defend AWACS. And then looking at the overall picture here, so when you have combat air patrol, ground alert intercept, and also surface-to-air missile defense as well. So this is a much bigger mission engineering threat, but this is more comprehensive. Other things you can do. What we saw with the conduct combat air patrol sortie is that was just at the overall uh, mission level, like, right? So very high level, but then you can go down to into more details. In this case, into the tactical and maneuvering level as well, right? So this model is to show for when you have a when your combat air patrol fighter has a near peer enemy, right? And then you can model different types of maneuvering, different types of weapon employment, right? In this example, not only do you model the behavior of the combat air patrol aircrafts, but also the actions from the enemy, the Red Force here. And then from here you can do a lot of other analyses such as sensitivity analysis, right, with probabilities, duration, resources for both the Blue Force and the Red Force, to then see how effective your tactics are, right? Your weapon employment and maneuvering tactics are with the sensitivity analysis. And then with this, we have the next poll question.
Great, Daniel. Thank you. I will launch the poll. So the next poll is all about how your program or company usually validates and builds a product. So do you have in-house experts that you use to test the product? Do you have third-party consultants? Do you use your customers? Or are you still questioning what validation is? So we'll leave this open for about a minute. All right, looks like the responses are about in. So I'll end the poll and share the results. So 65% say that they have in-house experts that they use to test. 6% say they use third-party consultants. 29% say they use beta testers or customers. And I guess most importantly, it does look like everybody at least understands what validation is. 0% answered what is validation. So with that, any observations or thoughts, Daniel, on the results of the poll?
So this is very interesting. I intentionally left the using the customers as the beta testers in there, um, as a way as a banter really. But this is very interesting because there are still some designers out there not having a more like a formal validation plan, and still releasing products out there, and hope that bugs and stuff will be uh, will be identified by the customers, right? So we want to move away from that, to be able to have a formal plan to validate the usage of the system. And that brings me to the point of the benefits of mission engineering, right? From the designer perspective, is that because we already um, modeling out the usage of the system early on, right? To look at the operational context, so that very model can become your validation testing model as well, right? Because you're already showing how the system is used. Might as well reuse that as the basis for your validation test. So with that, let's go back to the presentation. All right, so excuse me. Right here. All right, so with that, let's look at a recommended process, but at the very high level. So this is based out of the mission engineering guide from the DoD, right? So you want to start with a very precise problem statement, right? What you're trying to achieve, and then characterize the missions, identify mission metrics, right? MOP, MOE, MOS that we talked about, and then identify the mission threats, mission engineering threats, right? MTs and METs. And then, very importantly, perform analyses, right? Now, I put this in red here. This is very important because for any type of trade study or any type of analysis, what we have seen so far is just is related to system models, right? The descriptive system models. There are other I'm sorry, other engineering models out there that would be very, very beneficial to your analyses, your trade studies, such as specialty engineering models, right? Reliability, maintainability, and so on, right? Management models, design models, manufacturing models, right? V&V. So just keep in mind that what you can do with an MBSA tool is just that it will give you a system model, but then you have to rely on other engineering models to perform a comprehensive analysis, right? And document everything, and then of course repeat the process for different missions, mission scenarios, and parameters for each of those missions. Right. So just from my perspective, recipe for success is that first of all, of course, you need to know if mission engineering is right for you, right? Even though the example here is from a Department of Defense aerospace perspective, but mission engineering is more applicable to other systems as well, right? So, for example, systems of systems with complex operating environments, right? Every time that you see operating environments, right, it's all about how the system is being used, how the system is being fielded, deployed, So mission engineering would be beneficial for that type of understanding of the system context. Right? System with many users or many user types, right? So how the more complex that interaction is, the more you need to understand how the system is being used, right? System under regulations and restrictions, right? One of these stakeholders or actors can be the governing bodies of some sort, right? So system under regulation and restrictions. System require long-term planning with long-lasting lifetime. So this is where the low coupling and high cohesion between the operational domain and the system domain come into play, right? So as you plan and develop and design for the system implementation, you can continue to study the operational aspect of that system as well, right? So we want to have the low coupling and high cohesion between the two domains, and mission engineering can provide that type of concepts and definitions for you to do two analyses, two types of architectures in parallel, right? And very importantly, integrate the operators, the users, right, early and intimately in your design process. So if you think the whole process as in the concepts of DevOps, right, for software engineering, just expand that concept into the entire engineering process. So as you design a system with requirements, right, with implementations include, you want to include your operators, your users early on, so that they can help you validate whether or not you are building the right system and not just building the system right. And then finally, um, even if you have in-house expert to help you understand the system context, let the designer, the engineers live a day in the life. In the system context, for example, if you are designing um, an aircraft carrier systems that would have to operate in the carrier environment, maybe send your engineers to live on the boat for a few days to observe deck handling, for example, launch and recovery, right? So these are the actual pictures that I took in '09 on the Nimitz, right? When they conducted carrier qualification off the coast of Mexico. Right, so I was able to live with the sailors, like both the enlisted people and the officers, and understand their days in the life. Right, so that's me on the Nimitz. Had a great time and also learned, how my system will be used on the boat in the same operating environment. And with that, we can move on to Q&A.
Great, thanks, Daniel. Thanks for the interesting presentation. There have been a number of questions that have come in via the question window. I guess I'll start out by sort of summarizing. There are several questions that were sort of related to asking questions about the modeling languages that are being used. So DODAF, UAF, the NATO modeling language, et cetera. Can you kind of comment on what you were using in the presentation and what the benefits of it are versus some of the other languages, differences? Just comment on the different types of languages out there and how they all support mission engineering.
Yes. So overall, a modeling language is very important, right? So it's a foundation of any type of MBSE or mission engineering. Without a language, a good language, you cannot be precise, you cannot be expressive uh, in your modeling, right? So I would say that it depends on the scope of your system, right? The scope of your operating environment. Uh, pick a proven language. For example, UAFs coming up, right? It will bring a lot of benefits to the defense and aerospace environment industry, right? Because it will give you a lot of rigor, a lot of specific specifications on how to have different viewpoints and aspects, right? The very specific meta models, and also the guide of how to do mission engineering, and also the language. But organization is familiar with as a starting point, and then explore other languages.
Great, thank you, Daniel. Looks like, at least for me, it cut out a little bit there, but I think I got the gist of it overall. There are a number of questions here as well about sort of where to start. So there's a question that asks, if mission engineering is an enterprise approach, do we start with an OV1 DODAF and then decompose SE to the mission?
All right, so OV1's composed you. So I would say that again, it depends on. So I assume that the question is from a designer in a Department of Defense perspective. Uh, Quickly, yes, but what you're talking about is that you're relying on the view to then guide a process, which I would caution against a little bit. So the views should be the outcome of your process of your model, rather than uh, having the view dictate how you run your process. So overall, yes, I would say yes, OV1 is a good starting point, but then you have to understand why or how you generate that OV1 to begin with, right? So try to go from understanding the missions, understanding the capabilities, and then build your model, and then your views should come out of your model, rather than having your view dictate how you model.
Great, thank you, Daniel. So there are several questions about the explicit schema that you used for your example. Some have called it your schema, others have called it your meta model. Can you comment on what you were using there?
So the example was based on my past experience with at Northrop Grumman. So we use DODAF. So a lot of those concepts are coming out of DODAF, and then with Genesis, we use the capability architecture development schema that would include those classes and relationships. But yeah, that's pretty much it. Just DODAF oriented concepts.
Okay, great, thank you. So there's a question around how this applies or doesn't apply to products or systems in a non-DoD or military environment. Is this still applicable to commercial products? Does it matter?
Absolutely, it does matter, because outside of DODAF or aerospace, you will not even hear or know of the concept of mission engineering. So there are a few things that your company or your organization would do without even knowing that you do mission engineering. So such as if you do market research, for example, if you run focus groups to understand the market, to understand the needs and of your customers, understanding how a customer would use your product, would use your phone, for example, your smartphone. That's basically doing mission engineering without knowing that it's mission engineering. So these concepts are more widely applicable than some of us might think, right? Some of us outside of the DoD context might think.
Thanks for that answer, Daniel. So, as a follow-up to that, there's another question, sort of the scope and the applicability of how far do you go in mission engineering. So the question is, Is mission engineering more about using systems in multiple different scenarios, or more about understanding the use of a system in a system of systems context through time?
I would say both. Now, in your specific scenario, right? In your specific application, uh, you can ask the question where the return of investment is, right? So from my perspective, where I see the return of investment is when I can come up with meaningful system requirements, right? So because it's all about designing, right? It's as a designer, right? So I'm speaking from a designer's perspective here. As a designer, uh, I am happy when I have a very meaningful, precise, and practical set of system requirements, right? So how do I get there, right? It doesn't matter if I have a lot of different scenarios, like mission scenarios or operational scenarios that I play with, I do analysis on. If I cannot get to my set of system requirements, that is all useless, right? So you might have different priorities to go either route, but just think about when you can provide, right? When you can arrive at the system requirements and also the implementing functions, right? That is your target. That's your end goal.
Great, thank you. So I'm going to try to combine two questions sort of into one. Again, I think there's sort of some common themes being asked here. There's a question about, do you generally consider mission engineering to be different than systems engineering? Or is it that mission engineers are more focused on use cases to ensure the development of requirements?
Uh, Very good question. So, if you noticed, if throughout the webinar, I try to emphasize that uh, the mission engineering example here is from the designer's perspective, but mission engineering as a discipline is much bigger than that, right? Because the at the DoD level, they will apply mission engineering differently, right? With mission as their system. So I would say that from the designer's perspective, mission engineering is focusing on the operational domain, the usage of the system, and then system engineering would then interface with mission engineering at the system requirements level, right? So mission engineering will provide you with your implementing functions and your system, high level, top level system requirements, and then your MBSE, the typical MBSE or the typical system engineering will start from that point on, that point forward.
Great, thank you. I think you answered the other question. There was one about whether it makes the question makes the claim first that systems engineering starts with requirements. Mission engineering seems to start before requirements. But it sounds like you sort of answered that in your last response as well. But anything else would you like to comment on there?
Right. I think that yes, you hit the nail on the head. Not all customer requirements are good requirements, right? So even though we are not responsible as a designer, we're not responsible for the customer requirements, but by doing mission engineering, we can almost verify if they are good requirements or not. So yes, if you have customers with good requirements, you're good. Maybe you don't need to do mission engineering, but how often can we claim that, right? So it's still kind of our responsibility to look at the operational context of the system, right? To then verify that yes, my customers' requirements are good, and valuable to my design.
Thank you, Daniel. This is an interesting question, and it talks about evolving requirements with time. So the question states, operational conditions necessitate a need for system architectures that will be effective for the duration of the mission, but evolve to new system architectures as the mission changes or the mission evolves. What are your thoughts on that? How does mission engineering support that, or how do you evolve or deal with changing mission or new threats as the mission evolves?
Absolutely. So this is where mission engineering can play a big role as in parallel with your system design, right? So back to my point of having a low coupling but high cohesion between the mission model and the system model, right? Since you are being very explicit about the two different domains, right? Even though they are have very low coupling in between them, and in my model you will see that low coupling as implemented by the relationship implemented by, but at the same time they still have high cohesion, right? So because you have two parallel models going forward, you can continue developing your missions architecture, right, with new scenarios and new parameters. At the same time, looking at your different options to then implement your system in the system domain.
Great, thank you. I know we're approaching the top of the hour. I'll ask Daniel one or two more questions, and then we'll have to wrap up. And as Amy mentioned, we will not be able to get to all the questions here in the live session. We will try to follow up via email with all of you that have asked questions after the webinar as well. Thank you for all the questions. There's just more questions that have come in than we'll have time to answer. Um, but in the interest of time, I'm just going to pick a couple more. How do you measure mission assurance from the proposed system that's been developed?
To measure mission assurance. Uh, to be honest, it's that's not a concept that I'm familiar with, so I will have to get back with you afterward.
Okay, thank you. Um, what are some best practices to using the system model driving mission engineering to help arbitrate between conflicting priorities between the users and the system builder?
I'm sorry, guys, can you repeat the question?
Let me see if I can sort of rephrase it. I think
Okay.
the question is asking, do you have any best practices that you could share um, for using your system model, so your system of interest model versus your mission engineering model to help arbitrate between conflicting priorities between the users or end stakeholders and the system builder, so the enterprise that's building the system? Are there any
Very
best
good. So
practices? Yeah.
right. So it goes back to the practice of a trade study, right? So because you have low coupling and high cohesion, you can possibly have one mission scenario with multiple implementations in for the system, or the opposite. You can have multiple usage of the system, but then they are all tied to one system implementations. So you use that to your advantage. You can pick and choose whether or not you have multiple usages of a system, but then you can tie all of them back to one shared implementations, or you can look at different options that you have in the trade study to have different ways to implement the same usage, but with different behaviors or different physical implementations.
Great. Thank you, Daniel. And with that, we're going to have to wrap up. Thank you for all the questions that continue to pour in. We will get to those. But just a couple closing comments. That concludes our webinar for today. I'd like to thank Daniel for sharing his interesting information with us. You can connect with Zukin and Vitech on LinkedIn to continue this conversation. And again, we'll reach out to everybody that's asked questions as well. I hope everybody's found the webinar interesting and helpful. As we've mentioned, an on-demand version of this will be available within the next 48 hours for those that want to view it again or share it with a colleague. Thank you again. There will be a exit survey that's sent out. It's a quick single question. We appreciate your feedback. If you have the opportunity to fill that out, it helps make our future webinars even better. With that, I'd like to thank Daniel again, and thanks to everybody who attended, and have a great rest of your day.